Close your eyes. I'll give you guys a commonsensical question. If I give you guys ghee and groundnuts, will you be able to make a snack? I hope the answer is no. If it's yes, then you're wrong. What is missing over there? A source of heat. Is it not? Now, if I give you guys water and rice, will I get an end product which is cooked rice? All right, here too we need a source of heat. And water being in liquid form will not help. It has to start boiling and all of that, is it not? It needs to reach a certain temperature, right? So what we are trying to tell is just having the product, just having the reactants will not give us the product. The surrounding environment, right? That is the environment. It plays a role. That's what I'm trying to point out. So we need to document in many of the cases the reactions environment. And also we need to make a note of the reactant's physical state also. It also plays a role. I'll give an example. So let's start off with physical state. So the physical state, the purpose is to make the equation more informative, including the physical state of the reactant and the product. So what are the different physical state that we generally come across? We have solid, liquid, gas, and aqueous. Aqueous is a scenario wherein you have your material dissolved in water. So this is basically the solvent. I hope I'm right. Solvent, solute. Let me think about it. Yeah, this is solvent only. Water is the solvent. Solvent. The one which is dissolving the stuff. Okay, so these are the 4 physical conditions that we'll generally use, not more than this. And for example, we have iron in presence of water. Okay, iron in presence of water, giving us some Fe3O4 and all of that. That is your magnetite actually, solid iron oxide plus hydrogen. It's important for us to understand that here the iron is in solid state, water is in steam form, that is gas, right? G stands for gas. It leads to Fe3O4, that is your iron oxide, and hydrogen gas. So I'll give you a physical example of this. We have a washing machine. Okay. So the washing machine, the service person, right? He told us as and when the entire process is done, that is the wash is done, to open the door and keep it open. Obviously open the door means keeping it open. So he told us not to close it, just keep it open. If you don't even take off the clothes, say it takes you half an hour, 1 hour, whatever it is, you're not taking out of the clothes, at least keep the door open. Why is that? To avoid this, right? There are parts in the machine that is made up of iron or any metal. Forget about that. Not only iron, say any metal. It should not go through this because there is steam in it. There is steam in it, and steam, the physical status of water, it is of gaseous form. Gaseous form has higher energy. This is higher energy, and this can react more rapidly than just water. Right? Do you guys agree? So what I'm trying to tell is the physical status also influences, not also, it also, yeah, actually also influences how fast the reaction happens. So it is a factor. Okay, guys, I'm trying to make you guys feel that yes, we need to indicate the physical status in many of the reaction. I'm making you guys be aware of it. If not, the topic is just this, that in a given equation we can also write physical status. S stands for solid, L stands for liquid, and G stands for gaseous form, and AQ stands for aqueous. That is, you're dissolving something in water. That's all you need to know. But again, you need to know the purpose of knowing that, right? Because things in gaseous form, they react faster. This knowledge helps us in many ways when you see the uses of chemical reactions and all of that. that is the last set of videos, you'll get to see that having this physical state, the knowledge of it, right, it leads to a certain product that can be used. Or in this case, we need to avoid this. When you open the door, what happens? The steam goes out, the temperature inside the washing machine, it reduces, and so on and so forth. So the probability that the steam continues to be there, it reduces. If you close the door, then there's a lot of steam. It's held over there. Right? Does it make sense? So the topic is documenting reaction environment. The very first thing is the physical state of the reactant and the product. It's important for us to know because of small set of reason I gave you guys. Right? There are many reasons, but I'm just giving you guys an introductory part. And also not only the physical state of the material, but also the surrounding reaction condition. Condition like temperature, pressure, and catalyst can be written above and below the arrow. This too is an important set of information that is need to be presented in our chemical equation. For example, cooking rice. If I just give you guys rice and water, uncooked rice and water, that will not feed us. We will not be able to feed ourselves with that. We will not be able to feed someone else. We need a source of temperature over there, right? We need the certain temperature over there, and that too plays a role. So how do you represent it? You can write a chemical equation and end of it conditions. This is also a standard form, or generally in your books, this is how it look like. You put an arrow, right? And you write 340, okay, atmospheric pressure. And this leads to the product of CH3OH, liquid state. So this is another way of representing. I typically write this manner. It's much easier to look at, right? Or you can write in place of that, you can write this as well. Conditions 340 atmospheric pressure. So if your handwriting is as bad as mine, you guys can do that. Okay guys, I hope I convinced enough for you guys to give importance to the physical state of the reactants and also the product and also the surrounding in which the reaction is happening. It's important as well. Okay, so you can pause and copy this.